Okay, so now we're going to talk about functions, and we're going to start with a definition of a function. Now, we have kind of an intuitive definition of a function. If you recall, we have set A, which might have 1, 2, 3, and we have set B, which might have A, B, C. And then a function defines the mapping from A to B. I'm going to make that one go there. So we say that if A and B are sets, then a function, in this case, a function f defines a rule mapping A to B, right? That's what a function is. You know what, let me change B a little bit. Let me make that a little bit bigger. And let's say that B also has D, all right? So our function f is a mapping from A to B. Sometimes you'll see that written as f and then colon and then A with an arrow to B. Sometimes you'll see f of x, where x is a member of A, to y, where y is a member of B. You might see that type of notation. The key thing is, if you're going to call it a function, you have to specify the domain, you have to specify the range, and you have to specify the rule. In this case, our domain is very simple. It's 3 numbers. Our range is very simple. It is 4 letters. And our rule is very simple because we're able to draw arrows that indicate it. For more complicated functions, we need to describe that rule because we might have an infinite set. We can't draw all possibilities for an infinite set. But somehow, every definition for a function has a domain, a range, and a rule that maps the domain to the range. Because we're going to use a few different ways of writing functions in this segment, right? We're going to have 1 line, 2 line, a few different ways of writing this information. But I want you to be able to pull those 3 things out: the domain, the range, and that rule. All right? Oh, another term you need to be familiar with: image. Right? Now, in this case, the range for B is ABCD, but the image is ABC. When we talk about the image, we only mean the values in the range that can actually come up based upon the values in the domain, right? So from A, the only values that we, f at 1, f at 2, f at 3 leads to A, B, C. D never comes up. So D is part of the range, but it's not part of the image. That's an important distinction. So if you think about it like this, let me give you an example. So if our f of x, x and y are members of positive natural numbers, so our function is going to be x times 2, right? In this case, the domain of x is all natural numbers. The range, all the possible values of y, are in all natural numbers, but the image is even natural numbers, right? Because we're multiplying by 2. So we get 2, 4, 8. So y can never take on a value that's odd. So the range, even though we've defined the range to be natural numbers, the image is only odd values. Could we tighten our range in this case? Yes, we could. But this is a totally correct way of defining our function, right? So that's the difference between the image and the range. And again, let's have A is 1, 2, 3. I'm going to put it under here this time. And then B is going to be A, B, C, D. And then we'll put the same function again. This is a and b and one particular function f. Let me write that down there. Boop. Let me write, yeah, this is f. The set of all functions from a to b is written as BA. Why is it written as BA? Well, because the size of all functions a to b is equal to the size of b raised to the size of a. So in this example here, f is a member of that set of all functions from a to b. Let me draw a few others. So this is another function. So green is a different function. Put that down there, and we'll call that G. And then we'll make orange. Yeah, we haven't been using D. And then orange will be set H. So all of those are different sets in B to A, right? B to A is the set of, all of those are different functions in the set B to A. B to A is the set of all possible functions from A to B. Later on, we'll talk about why this function is correct, but let's just do the math here real quick. The size of B is 4. The size of A is 3. So 4 to the 3 is 64. There are 64 functions that can map A to B, 64 possibilities. And again, we'll explain why later. Okay, one final bit of notation that I want us to have before we move forward. So you may notice most of our sets are 1, 2, 3, A, B, C. You know, they're a sequence of symbols that we already know the pattern we're used to. So instead of writing like a set of 1, 2, 3 on down to say 57, we would just write 57 underlined to describe that set. Or whatever n is, yeah, let's make this all mathemified. Instead of saying 57, let's say n, right? Then we'll just say n underlined. N underlined always means 1, 2, 3, all the way up to whatever n is. And that'll be nice and general. Okay? That is all of the definitions that we need at this point to understand functions. If you have any questions, ask in the forum below.